So the first thing that you want to do is you want to know what's the parent function here. It's a square root.
Yeah.
Right? So if I graph it, when x is, we're just doing the square root. When x is 0, y is 0. When x is 1, what's the square root of 1? 1. And then you'd want to go to 4 because you want a perfect square. The square root of 4 is, so there's the parent function. Then the next thing that you would do is you want to make sure that you do any reflections. Is there any negatives out front? Is there any negatives with the x? So it's not reflecting. And a stretch or compress, that's this. That's a stretch. So if it was a stretch on the x, it would be with the x. Anything that's out front of it means it's about the y. So if there was a negative out front, you'd be reflecting across the x-axis. If there was a negative with the x, you'd be reflecting the y-axis. You got to watch 1.6. So this is a stretch on y. That means all my y's are being multiplied by 3. So here's my y. What's 0 times 3? And y is at 1. What's 1 times 3? So it's stretching it up. And then this one would be at 2. What's 2 times 3? 6. So 3, 4. So it would be up here even more. I'm going to just use that one. So there's a stretch. Okay, so this was y equals 3 times the square root of x. This was y equals the square root of x. Now there's one more thing that you have to do to this function. This right here, is this, what's kind of shift is this when it's with x? It's with x, so it's a horizontal. It's about the x. Now, am I going to add 1 or subtract 1 to all my x's? So my x would actually want to move, all of them would want to move back 1. You don't go back to the original one. So I move this one back 1 and this one back 1. So there it is, shifted back once. I would say that this one now equals 3 and the x plus 1. So you're doing each one of them.
That one is like, take the opposite.
So anything that's with the x is the opposite. Yeah. So it's not going to positive 1, it's going to negative 1. So yeah, I keep them pretty basic. I don't get really in depth with them when I give worksheets. I just want you to know the basic ones and how to move them around. And so I would have labeled each one of these. 8, is there reflection? None. B, identify a stretch or compress. It was a stretch. It was a stretch.
And if it would be a compress if there's nothing?
Factor of 3. So it was a stretch because it was a 3, but if it was a 1/3,
so
then it would be compressed down here. But now with the x, if there was a 3x, would it be a stretch or compress? Because it's the opposite thinking, it's with the x. So if it was 1/3, then it would be stretching it. If it was a 3, so, okay, that's what 1.6 is about. All right, so stretch by a factor of 3. And we had a horizontal translation on the x. We had a stretch by a factor of 3. We had a horizontal left 1 unit. And a vertical translation. No, nothing is being added or subtracted to have it go up and down, so none. And that's how you do a sequence of transformations. Okay, starting with A. Is there a reflection? I keep referring back to this. Is there a reflection? Well, I don't see a negative out front. And I don't see a negative in front of the x, so that would be none. B, identify a stretch or compress. So it can be a horizontal or a vertical, and it can be a stretch or a compress. So I'm going to look out front. First thing I'm going to do is graph my function, the square root function, and then 4, 2. Now I'm ready for a stretch out front. This is a stretch of 2. So that is on the y. It's not with the x. So that would mean that it's a stretch on the y-axis. So if it's the y-axis, we have a vertical stretch. Factor of 2, stretching by 2. So I'm going to multiply 2 to all my y values. 0 times 2 is still 0. 1 times 2 is 2. 2 times 2 is 4. That is a vertical stretch. So y equals 2 square roots of x. I stretched it. Are there any others? There's no number in front of x, so that means there is no stretch or compress for x. Moving on. C. horizontal translation. That would be here. Horizontal is on the X. And so we have horizontal, and where are we going? Not to -2, but +2. So right 2 units. So everything's going right by 2 units. 1, 2. Oh, you make sure you use the one that you just used. You don't keep going back to the original. So over 2, over 2, over 2. That would be y equals 2 square roots of x minus 2. The last one would be a vertical translation, and we do have our y value here moving up to 3. So this would be a vertical translation. So vertical, and we're going up 3 units. So I'm going to take all my points and I'm going to move them up 3 from the last one that I just worked on. 1, 2, 3, 1, 2, 3, and 1, 2, 3. This would be the complete function. Y equals 2 x minus 2 plus 3. Okay. A says, is there a reflection? We do have a negative here. I'm going to start with the original. Here's the original square root. Okay. So the negative is out front of the function. It's not with the x. I'm negating the y value then. If I'm not negating the x, that means when it's out front, you're actually negating the front of the function, which is f of x. So when I negate my y value, what does that mean? I need to change the sign on all my y values. Let's see, I need to think about this for a second. To reflect x-axis, you negate the y. To reflect the y-axis, you negate the x. Right. So let's see what happens when we change the sign on all of the y values. This is where y is 1, and now it's going to be down at -1. We're reflecting across the x-axis. This is at 2, so it's going to be at -2. So what we just did was we did y equals negative square root of x. So A says, is there reflection? Yes. So we reflect over the x-axis. When we have the negative y, we reflect over x-axis. B says, identify any horizontal or vertical stretch and compress. Okay, we have a number again that's being multiplied out front. It's not a whole number, so it's not a stretch. It's a fraction, which means we're compressing it down. I need to half all my y values. So this is about halving our y values. This is going to be a compress. Okay, so if y is 1, what's half of that? It's a half. If y is 2, what's half of 2? Here we go. We are compressing it and shrinking it towards the x-axis. So y equals a -1/2 square root of x. identify, C, any horizontal translations. This time we don't have anything happening to the x. This is on the outside of the square root, so there would be no horizontal shift. How about a vertical translation? Yes, we're going to be moving up 3 units. That means that we are adding 3 to all of our y units. So we would say a vertical and going up 3 units. I'm at a half, so 3 units up. 1, 2, 3. I should still be at the halfway mark. At -1, so 1, 2, 3. And here it is, coming down. Y equals a -1/2 x plus 3. And we just shift it up 3 units. And there we are. That is how you do transformations in a sequence. You have to know what the parent function is. Here it was all square roots, but if it was the absolute value or a parabola, it would still be the same thing. You do a sequence of translations. You could practice over here if you wanted to practice some more, but I'm going to leave it at this. 3 examples of what it means to translate and transform, stretch and compress. This was just a review to really help you see what it means to be a transformation. Try to get everything done up to your review for next class. We'll see how it goes. It may be another quiz. It may be the test. Please be prepared for a test. I will correct your homework all weekend long, whatever you pass in. And so you should go back and look at, be ready to ask questions during the next class.